Hello all, welcome to this course on time series modeling and forecasting using R. Okay. Now we are almost through this week, and then again just to give you a very faint idea as to what we covered this week is that, so the broader topic throughout this week was modeling volatility using different kinds of time series processes. And then throughout this week it has been slightly heavy. I can understand that. Again, if you are not very confident about some of the material we have covered this week, so again a very strong suggestion would be again to go back and then watch those videos diligently, sincerely, maybe take some notes on a separate sheet of paper wherever required, because all these modeling techniques are slightly on the newer side as compared to all the models we have seen so far. Okay. And again, just to press on the fact that we have seen number of different models, and then many of them were kind of extensions of that Garch model. Okay. But at the base level, two very important models were studied this week, which were Arch and Garch. Okay. And both of these models had capabilities of handling volatility and modeling volatility, and then trying to sort of capture the changing variance pattern which is seen in the practical data set. Okay. Now this is as you see in front of you, so we have an R session open up, and then we will be simulating a few Arch processes initially, we will be simulating a few Garch processes initially, and down the line we will try to fit Arch and Garch processes on some real data sets as well. Okay. But again, just to again ensure one important point is that you should keep in mind that where exactly can you implement Arch processes or where exactly can you implement Garch processes, etc. So there has to be some changing variance pattern which is seen evidently in the underlying time series. If you do not have any changing variance and then you seen that the variance is kind of constant, then obviously applying any of the Arch models or Garch models or their extensions does not make sense. Okay. And of course, just again a very quick refresher as to towards the end of last session or maybe last to last session, we have covered number of extensions of Garch processes. If you remember, so GJR Garch, exponential Garch, threshold Garch, right. So all these have capabilities of controlling the symmetricities or asymmetricities which are seen in the data set. Okay. So here we will open up a new fresh R worksheet, and then initially as discussed we will sort of try to implement some of the Arch processes and Garch processes on some simulated data sets. Okay. Okay, so as always we will start with incorporating some packages. So the first one is fgarch. So obviously fgarch has not been used earlier because fgarch is sort of persistent or only focuses on capturing the Garch capabilities of a time series. So we will involve that in the R environment. Now again, just one disclaimer that if you have not installed the packages, again you have to go to tools and then click on install packages, and then you can write down the name of the package here and then click on install. Okay. So assuming that you have all these three packages installed in the R environment, then obviously you can call them using library or require command. Okay. Alright, so the first package is fgarch, second package is rugarch, so again pertaining to a Garch modeling setup, and then the third package I think we have used in some of the earlier R sessions as well, which is called as quantmod. Okay. So we will again make sure that again one very important point is even if you call some of these packages, you have to again make sure that you do not get any errors in the console. Okay. I mean, once a while due to some connectivity issues or some mismanagement in the package itself, it might happen that R might throw some errors here, and then again you to sort of Google as to what that error means, you do a little back and forth. But if you do not see any errors here, then you can assume that all the three packages are successfully loaded. Okay, so as discussed a short while back, so the first initial task for us today will be simulating a bunch of Arch processes and Garch processes. Okay. So again we will specify some set seed. So again, just to make sure that all of you understand the role behind set seed is that if you want to replicate this a number of times, then R will ensure that every time you will get a randomized kind of an output. Okay. So it will start with the same thread or rather the same number 1, 2, 3, but it will produce a randomized output every time. Okay. Alright, and then we will specify how many observations we want. So n is 1000 here. Now again one small point is that you can give any random number here. So we have given 1, 2, 3, but then you can give any random number. So once you give any number here, let us say 4, 5, 6 or whatever you want, so R will keep that number in memory, and then every time you try to replicate the same code, it will start from the same set or same seed value, which is 1, 2, 3 in this case, and then try to replicate the entire experiment as if a randomized trial is happening. Okay. So hopefully this part is clear. I mean set.seed 1, 2, 3 or for that matter any number is more from a syntax point of view. Okay. Okay, so now once you specify how many observations you want, we have to specify all the parameter values. So let's say omega is 0.1, then alpha 1 is 0.5, beta 1 is 0.4, and then alpha 2 is 0.3. Okay. So we are keeping some values of all the relevant parameters beforehand. So until line 11 we haven't specified the model, right. But again, if you are not very confident about the model structure, you may have to again go back to some of the earlier sessions this week and then try to understand as to how the arch model looks like, or how the general Garch model looks like, and so on and so forth. Okay. Alright, but just in case we are trying to specify all these parameters beforehand, so that later on once we will start specifying some of the models, let us say Arch 1 or Garch 1 etc. So you need not specify all the underlying parameters again and again. Okay. So you can keep all the fixed parameter values initially itself along with n. Okay. So again, just to recap very quickly, we are specifying these 5 quantities predominantly. So n, omega, alpha 1, beta 1 and alpha 2. Okay, so now the very first exercise, or rather the very first model we will try to simulate is a simple Arch 1 model. Okay, so autoregressive conditional heteroscedasticity with order of 1. Now again, just for time brevity or time paucity, I will not discuss the model structure here. So we have discussed each and every model structure which you see here in detail, right, or it might happen that we might have sort of talked about arch M in general, where M is some generalized order, but again wherever you have M, if you replace M with 1, it will give you arch 1, okay, or if you want the order to be 2, right, so you extend that model up to that point, okay. So obtaining some specialized models, so by specialized I mean obtaining some fixed order models, let us say arch 1, arch 2, arch 3, arch 4 etc. shouldn't be a problem if you have the general arch M model ready with you. Okay. And the exact same story with Garch model. So if you have the general model structure for Garch PQ, so wherever you have P, if you replace 1, and wherever you have Q, if you replace 1, it will give you a Garch 1 model. Okay. So hopefully writing down the model structure or understanding the model structure should not be a problem here at this stage. Okay. Alright, so the first model we try to simulate is simulating an Arch 1 model, and then we have this very convenient sort of a function which is inbuilt in R, or rather inbuilt in one of the packages we have loaded earlier, which is called as Garch sim. So Garch sim of course stands for Garch simulator. Okay, so this would be a simulated sort of a Arch 1 model. Now again, one point to notice here is even if you are simulating an Arch 1 model, but then the function name is Garch. Okay, because probably as all of you might know that Arch is one special case of Garch, right. So Garch is sort of an extension of Arch, or rather Arch is a special case of Garch. So R does not kind of differentiate between Arch sim and Garch sim. Okay. So using this Garch sim, you can still simulate from an Arch 1 model. Make sense so far? Okay, so initially we will give it a name, let us say Arch 1, and then we will try to run this. And again here all this is part of the syntax. So let us say model equals, and then here if you see, you specify the parameters. So omega, alpha 1, beta, and then lastly how many observations you want. So I want 1000 observations, which is nothing but n. Okay. So once you specify this entire chunk of code and give it a name, let us say Arch 1, I will show you the plot of the simulated Arch data. Okay. So let me zoom in. So this is exactly how the simulated Arch 1 model looks like. Okay. And clearly here you might not be able to sort of see the changing variance, but again if you look slightly deeper, you may find out that this is highly volatile, right. So again by highly volatile I mean that you have some abrupt ups and downs throughout. Okay. So one can't find out some fixed horizontal bands in which the entire series could be encapsulated. So in a way changing variance problem is there. Make sense? So this is and again the next time you try to simulate the exact same model, it might give you a different picture, because this is an entirely simulated sort of an exercise. Okay. Okay, but in any case this is exactly how a Arch 1 simulated model looks like. So which is highly volatile, right, and then changing variance could also be seen here to some extent. Okay. Okay, so we will close the plot, again go back to the code. Now the next model we will try to simulate is an Arch 2 model. So Arch 2 stands for, again we will use the same function Garch sim, and then again we will specify a couple of parameters here. So omega, alpha 1, alpha 2 etc. Okay. And then we will see that how the plot of Arch 2 looks like, and then whether you see any differences between Arch 2 and Arch 1 model. Okay. Okay. So we fitted Arch 2, and then we can give it a name, let us say Arch 2, and then this is exactly how the plot of arch 2 looks like. So, again I am using a slightly different color so as to differentiate between, let us say, arch 1 and then arch 2. Okay. Now, again if you look from a very broader perspective, you might not be able to spot any differences between arch 1 and arch 2, and then again needless to say that again all these exercises are simulated based, okay, and then arch 2 is nothing but one extra order than arch 1. Okay. So, you should not hope that any drastic changes in changing variance would be seen. Okay. Now, again one similar point to what we seen earlier is that this even arch 2 is highly volatile. So, you see abrupt ups and downs everywhere throughout the series, okay, and hence changing variance problem could be clearly seen. Make sense? So, arch 2 is nothing but one extra order than arch 1. So, there is not a whole lot of a difference that you see here. Okay. Okay, but at least you should understand that how do you simulate, let us say, arch 1 model, arch 2 model, or let us say for that matter some higher order, let us say arch 5 model, etc. Alright, now the next model we will try to simulate is Garch 11, alright, and then this is the name we will give it. So, Garch 11, and again exactly as specified a short while back that the function name does not change. So, even here we have this exact same function name which is Garch sim, okay, and we will sort of apply this Garch sim. The only difference here is that apart from specifying omega and alpha 1, you might have to specify, let us say, beta 1 as well. Okay. So, these are the underlying parameters of a Garch 11 model. Now, just one small point to note, if you go up to where we simulated this arch 2. So, again since arch 2 is an extension of arch 1, it requires 2 orders. Okay. So, here you have to specify alpha 1 and then alpha 2, right, because you are sort of extending the order up to 2. But again if you notice we are not specifying any value of beta. So, we are kind of removing the beta from the equation because it is not a Garch model to start with, it is an arch 2 model. Okay. But the moment you come down to Garch 11, so in Garch 11 what happens is you have one order for the arch model and one order which captures the Garch model. Okay. So, here you have to specify alpha 1 and then beta 1 and then of course n and then omega. So, remember one thing that omega stays the same because omega is nothing but the intercept portion or the constant part of the model. Okay. Okay, so this is exactly how we can specify or rather simulate from a Garch 11 setting. So, again one important point to note here is that depending on which model you want to simulate from, you can actually specify those many parameters inside the Garch spec function. Okay. So, just to give an example, let us say if you want to simulate from an arch 5 model instead. Okay. So, again you can pause the video and try to answer my next question is that how many alpha values would you require? Again just to repeat the question, if you want to simulate from a arch 5 model, then the question is how many alpha values you would require to specify. So, again the answer is 5, right. So, one would require alpha 1, alpha 2, alpha 3 up to alpha 5, and again since the model is arch 5 you will not have any beta. So, beta would be 0 again. Make sense so far? Okay. So, we have tried to simulate from the Garch 11. So, we will run that and then again I will show you the plot. So, again as before, again hopefully the plot would not be a whole lot different from let us say either arch 1 or arch 2 because again Garch 11 is just an extension of let us say arch 1. Okay. So, again you can see that the series is volatile. So, probably an ARIMA kind of a structure will not do good here because you have lots of random ups and downs throughout the entire series, which sort of assumes the fact that variance is not constant or rather variance is changing over time. Okay. Alright, so this is the simulated data from a Garch 11 sort of a model and we can extend this further. So, just to show you one last simulated data. So, what would happen if you want to simulate from a Garch 21 model? Okay. So, again before showing you the sort of parameters we require here, again you may pause the video and then try to understand that what all parameters you would require. Okay. So, here for simulating from a Garch 21 model, of course you require omega, then alpha 1, alpha 2 and then beta 1. Okay. Because this Garch 2, so the first order stands for the arch component and then this 1 stands for the Garch component. So, there has to be 2 alpha values. So, alpha 1, alpha 2 and then since the Garch order is 1, you only require 1 beta value. Okay. So, alpha 1 again if you scroll towards the right hand side, you can see that omega, alpha 1, alpha 2 and then beta 1 and then of course n. Make sense? Alright. So, we will simulate from this Garch 21 model again using the exact same function which is Garch sim and then we will see how the plot looks like. Okay. So, this is exactly how the plot looks like. So, let me zoom in slightly And again, so probably here you can see one small difference is that the volatility might have increased slightly. So if you compare GARCH 1.1 with GARCH 2.1 or other ARCH 1.1, sorry, so not ARCH 1.1 but then ARCH 1 with let's say something like GARCH 2.1, you can see that underlying this model, you can see lot more volatility as compared to let's say either GARCH 1.1 or ARCH 1 or ARCH 2, etc. Now again, how do you judge that? So again, lot more volatility means that you have lots and lots of ups and downs of let's say increased heights. Okay, so the peaks and troughs are slight of, so in this GARCH 2.1 model, the highs and lows are much more higher and lower correspondingly as compared to let's say something like GARCH 1.1 or ARCH 1 kind of a model. Okay, and of course this would be one slightly different characteristic, because as in how you go on increasing the orders, you are trying to sort of control for that much of a complexity in the model, right. So obviously if you compare ARCH 1 and then GARCH 2.1, obviously GARCH 2.1 is an extension of ARCH 1. So GARCH 2.1 would be much more capable of sort of capturing highly volatile sort of a time series, or where variance is changing abruptly and much more predominantly as compared to ARCH 1. So hopefully all these points one should keep in mind. So again, this is again a simulated sort of an exercise, but how do you compare between processes? Okay. So tomorrow if somebody asks you that what exactly is the difference between let's say ARCH 1 and then GARCH 2.1, so okay, so again this exactly should be the answer. Okay. Alright, so now the next data is a slightly different data, and again if you are not very confident about its model structure, so we have covered this in the very last lecture itself. Okay. So again this is an extension of GARCH, and then you have two different components, so ARMA plus GARCH. Okay. So ARMA 1.2 plus GARCH 1.1 model to capture the volatility. So you have an ARMA model inbuilt to capture the mean structure of the model, and then you have this added GARCH 1.1 model to capture the changing variance. Okay. So how do you simulate something from an ARMA 1.2 plus GARCH 1.1 model? So again, as always, or rather as assumed, it would have a two leveled kind of a model. So the first kind of a model would be ARMA orders. So to specify the ARMA model, and then here since the model being ARMA 1.2, so the AR part corresponds to only one order. So AR equals 0.7, whereas the MA side corresponds to two orders. So minus 0.4 and then 0.3. So all these are fixed, by the way. Okay, so let me run the first level, and then the second level is to specify the GARCH structure. So ARMA GARCH is nothing but we will make use of this GARCH sim, right, and then again since the model is GARCH 1.1, we have to specify let's say omega plus alpha 1 and then beta 1 and then lastly n. Make sense so far? Okay. But then just one small part here is that since you are sort of inbuilding the GARCH 1.1 structure on top of this ARMA 1.2, so here you have to actually specify the ARMA structure beforehand. So ARMA underscore order, you extract the AR part, and then MA is nothing but ARMA underscore order, and then you extract the MA part. Okay. And then you specify these two orders here inside the GARCH sim model, and then the usual GARCH parameters, or rather the coefficients. Make sense? Okay. So let me run the second level model, which is ARMA GARCH, and then probably we will see the plot. So this is exactly how the plot of ARMA 1.2 plus a GARCH 1.1 model looks like. Okay. Now again, one small disclaimer is that you might not see huge differences between let's say ARCH 1, ARCH 2, GARCH 1.1, ARMA plus GARCH, right. So the whole idea is that as in how you are sort of slowly extending models, it should be capable of capturing highly volatile processes, and on the other hand where the variance is changing abruptly, okay, and much more predominantly. So this is the whole idea of all these extensions. Okay. Alright, so this is again just the simulated path of ARMA 1.2 plus a GARCH 1.1 model structure. Okay. Alright, so now the second exercise would be to analyze some real data. Alright, and then in this spirit, the first data we will try to analyze is analyzing the New York Stock Exchange data. Okay. So the very first thing is we have to fetch the real data, and then we have a way of fetching the real data from the R repository, or rather some online repository directly in R. Okay. Now again all these are syntax, so this would, so probably line 36 all the way up to line 38 would be sort of important if you want to extract any stock market pertaining data directly into R. Okay. by using this get symbols command, and by the way this command is inbuilt in the quant mod package, right, and then for that matter you require that quant mod package which we installed and then called earlier. Alright, so now the first exercise is fetching the NYSE composite index data, and then for that matter we will run this get symbols, and by the way this is the symbol for NYSE data, and then if you see here source is Yahoo, okay. So this data would be borrowed from directly from Yahoo markets, okay. And then here you can specify from, and then you can write down some date we want. So I want the data from 1st of January of 2020 all the way up to system date. So system date is today's date, or rather the current date, okay. So I want the data from that time period. So let me run that. So get symbols, okay. And then here if the line is being processed successfully, it will give you the code like this. So NYE. So this means that the R has sort of brought in the data from the Yahoo repository, okay. But again, so we may not want the entire data, right, because the entire data might contain lots of sort of columns. So what exactly we want? We only want the closing prices, okay. So obviously we can extract the closing prices. So and then we'll give it a name. Let's say NYSE underscore close, which would be close of operated on NYE. So extracting the closing prices. And now again we will not play around with prices itself, right, we want to play around with the returns, okay. So NYSE underscore returns is nothing but the first difference of log prices into 100, okay. So this small formula ensures that we are sort of converting the price data to a returns data. So as mentioned even here, it sort of computes the daily returns of the data, okay. So let me run this NYSE underscore returns. And then the last thing we do, so all this is sort of part of the data filtering process, okay. So the last thing we will do is to extract or rather remove all the NA values, because we do not want any NA values before we proceed with modeling and then forecasting, etc. Okay. So this is exactly how one can remove the NA values by using this na.omit command, alright. Okay. So we will try to run this again. So NYSE underscore returns. And now plot the return. So initially I will just show you that how the plot looks like, okay. Let me zoom in. So this is exactly how the NYSE plot looks like, and then clearly you can see that you have a changing variance problem here, because if you observe here in this period, which is nothing but the COVID period by the way, you can see highly volatile nature in the NYSE daily returns, but as in how the returns sort of progress down the line, you do not see any drastic changing variance problem, but if you sort of analyze this overall, you do have some changing variance problem. So this is called as a funneling in kind of a pattern, where initially you have high variance in this time point, and then later on the variance sort of reduces, okay. So how do you control this changing variance pattern? So we'll try to implement some of the Arch models or Garch models or their extensions, etc. Okay. Alright, so now the first model we try to fit on this NYSE returns data is fitting some Garch model. So we'll try to specify some Garch 1.1 model, okay, and this is one function to do that. So we'll try to use a slightly different model, which is ugarch spec, okay, ugarch spec, right. We'll try to run this entire chunk, and then here if you see we have to specify all the parameters. So we have to tell R that which model we want, okay. So since we want a Garch 1.1 model, you can specify the orders here. So C1, 1, and then if you do not want any ARMA models to be inbuilt beforehand, you can specify 0, 0. So mean model is, you do not have any mean model here. So ARMA orders are 0, 0, okay, but include.mean equals true. So this would tell R that there should be some overall constant or there should be some overall mean. Make sense? So all these are nitty-gritties when it comes to specifying a particular Garch 1.1 model using this ugarch spec function here. Okay. Alright, now the next thing is fitting the model. So how do you fit the model? So you can fit the model using ugarch fit command. I will show you the summary. So summary does not contain a whole lot, right, but now the plot. So this is exactly how the plot looks like. Let me zoom in, okay, and then this is exactly how the conditional standard deviation behaves vis-a-vis the returns, right. And as you can clearly see, so I think the blue line is the conditional SD, and then the light grey line is nothing but the absolute returns. And then can you see that the underlying changing variance component using the Garch 1.1 model is sort of able to capture the changing variance pattern in the data set, isn't it? So wherever you have high peaks, the model itself jumps to that peak and wherever you have troughs, the model itself is sort of on the lower end. Okay. So, in short, the GARCH 1.1 model is doing a very decent job. Okay. And now the next thing, or rather the last thing, is forecasting. So, how do you forecast this to a later date is, again you have an inbuilt kind of a function called as uGARCH forecast, and then you will specify which model to use. So, fit underscore NYSE, and then how much ahead in the time point, so which is 10. Okay. So, we will run the forecast and then we will run the plot. So, this is exactly how the plot of the forecast looks like, okay, along with the confidence bands. So, the blue line is the actual data, alright, and then this red line is nothing but the forecasted data. Okay. And hence you can extend this further, so you can specify, let us say, other models, let us say ARMA 1.2 plus GARCH 1.1, right. Now again the whole thing is that you have to specify, so again since you are inbuilding, you also have a mean model here, you can specify the ARMA order to be those orders. So 1, 2 along with the GARCH orders, okay. So we will try to fit this model instead now. So ARMA 1, 2 plus GARCH 1, 1, and then summary, and then plot. Now again the plot would not look a whole lot different again, right. So broadly speaking, and again if you scroll down, so since we do not have time in this session, I will sort of stop here, but just to mention that since you have access to the code, so probably, so the next exercise is using some other real data set, and then here we have a Bitcoin data, okay. So again if you are more interested in sort of modeling some ArchGARCH processes on Bitcoin data, you can again go ahead and then try to complete this worksheet, okay. So initially so far we have seen that how do you simulate from ArchGARCH processes, how do you model them, how do you forecast them, and then how do you play around with some real data, and then in this context we took an example of the NYSE returns data and then try to fit a GARCH 1.1 model and a ARMA 1.2 plus GARCH 1.1 model on the NYSE returns data, okay. But again just for the sake of that, if you want access to or sort of play around with another real data set which is the Bitcoin data, you can of course scroll down and then you can do the exact same thing on the Bitcoin data as well if you want. Make sense? Alright. Okay. So broadly speaking, this is the idea as to how can you simulate and then how can you sort of apply some GARCH processes, Arch processes on some real data, try to forecast, eventually compare the forecast, right. Try to specify some of the plots, or how do you sort of visualize the fits, how do you visualize the forecasts, right. So we try to cover as much as possible, and then hopefully this entire week would have been slightly more interesting because modeling volatility is kind of predominant or rather important, more from a financial literature or financial point of view, right. And then probably next week we will try to extend this entire idea, not volatility modeling of course, but slightly different kinds of time series models which is called a non-linear time series starting from next week. Okay. Thank you.